Hello, this is Dr. Wilkinson again. We're going to do a sub-assembly on the Amogo vehicle or robot that you've all seen a video for. This is a sub-assembly that's related to, it's on the, call it the front end of the vehicle, where it comes to pick up the goal, and then it loads the, dumps things onto the post. Now here's the goal, and it comes in with fingers that reach underneath the here on each side and picks up the goal and walks away with it. And it's these little extensions right out here that do the pickup. The other thing to keep in mind about, what I'm doing today is actually this end piece here, and I'll leave to you guys to do the equivalent end piece on that side. This structure is called a Fourbar. Fourbar thing. It's got a horizontal, top and bottom, two verticals, and effectively it creates a parallelogram, if you think of your geometry. And that parallelogram allows it to, I got to get my camera in a good place, do this kind of thing. So imagine this is sitting right here, and when you're parked, you can be back like this, and this arm out here doesn't extend past the front of the vehicle. Then when you want to reach out and get the goal, you can come all the way down here. It will, when it's out like this, it will be lower, and it'll be just close to the base of your vehicle. Again, my camera is not in a good place. And then as you raise it up like this and possibly move your vehicle forward, you lift up the goal and can back up and drive, and you can bring it back to wherever you want to do the handling of the thing. Just to keep in mind, here is a parts list. Mr. Nachman has an archival copy that you can use for purposes of, if you can't read this well enough, and that's possible. And this parts list doesn't really include screws. I think it includes everything else that you need, but the screws are really three sizes. There's half-inch screws, 3/4-inch screws, and 1.5 or 1.25-inch screws. Those three size screws will do it. I got the nuts out here. I've got some spacers. These are 3/8 inch diameter by 1/2 inch long. These are another spacer that's used right up here in the assembly. Here's the 3/8 diameter by 1/2 inch long example right there. This is a 3/8 diameter by 1/8 inch thick bushing or spacer that goes in there. These are cases of building up a part. Here's a typical axle clamp, 1/4 or 1/8 inch, the small square axle clamp for that. But you take out the set screw and you screw in just a headless threaded rod. It screws up into the standoff and screws down into the hole that you took the set screw out of. And here's what it looks like when it's finished. Other parts that you need for this are bearings. You'll find bearings in several locations. Here, for example, down below, for example, so up here, down below, and then you'll find one here and one here. So there's 4 bearings in the assembly. And so let's think about that. Anything else here in parts? Okay, yeah, here's a part that's used right up here. And if you use the 1.5 inch screw in this for this axle or shaft, you need to use this part. If you use the 1 1/4 inch screw, you don't need to use the part. And it seems to me that it works equivalently well. This is what's in the drawings provided by the team that built this unit. In fact, that raises an interesting point, is that team went all the way to making drawings of their final robot, and that's a pretty impressive accomplishment. So again, I want to come back to this here and try to show you a little bit more of the details of construction. Notice there's in this case, a 3/4 inch screw. I gotta get myself in a better holding position. It's a 3/4 inch screw coming through here. It's locked in place, making it a rigid shaft by a lock nut. And it comes through the bearing on this second member, and then is using a nylock nut to close it off at the other end. To hold the part onto the shaft. This is basically the same construction on the top, but in order to allow this part of the assembly to go past it, it's offset to the side a little bit, and so they put a spacer in here. They do the same lock nut arrangement. Then there's a spacer, then there's the bushing, there's the nut. So this pushes the top bar of the 4-bar assembly off to the side a little bit to then allow this structure to be attached to it. And this is all rigid. And I've pointed out before already about the spacers there, and the standoffs with the axle clamps, modified axle clamps. Here is one in front and one in the back. There's a difference in their length. That's in order to give this here pickup member a little bit of upward slope, so that it tends to hold the goal back towards the vehicle. It can't slide off the end. I guess if you notice here, if you were to look at this, this is actually the equivalent of a rectangle. The distance between the two axles, top and bottom, are the same. With the 4-bar assembly, you could deviate from that a little bit and you'll get a little bit funnier behavior. But the benefit of this is that the top member always stays parallel to the bottom member, so you can control the tip of that pickup finger, or pickup angle iron that's out there. So here again, what we're using is 1x2 channel at the bottom, 1x2 channel at the top, and if you look at the parts list, they're not exactly the same length. So the whole positionings with respect to the ends are a little bit different between the top and the bottom. But again, 2x2 channel, 2x2 channel. Here, 1x1 angle, 1x1 angle. My camera, I'm not using the camera well. 1x1 angle here, a 1x1 angle here, 1x2 channel here, 1x2 channel here, and then this here is a 2x2 angle. And that's these parts right here basically kind of laid out. I had to cut them all to custom lengths. None of them were stock lengths, which I know we've tried in the past with robotics not to cut the parts in the cupboard, the inventory, to specialized lengths, because then they tend to not have a future anywhere. And so Mr. Nachman could advise to do something to economize on use of parts, but maybe stay with something that's stock lengths. So I leave you with that. The only other thing to keep in mind is I've turned this picture around to look at the back side of that, and here it is looking at the back side of it. So here's Here's the Fourbar that I've built here and we're demonstrating. Here there is a 1x3 channel across here coming to another angle, and this angle is locked to this gear, and then this gear also, or this shaft also comes out to another 1x2 channel that's going to be screwed in the future, would be screwed down to the platform of your robot. So again, there's this screws down to the platform of your robot, this screws down to the platform of your robot, and up on our sample piece, it's this piece here gets screwed down onto the base plate of your robot. But here this comes across. This is the actual drive. In fact, in this picture it shows it better. This is the actual drive gear. It'll be screwed into these vertical uprights, 2 screws, and the shaft of this goes right through one of those square holes in the 1x2 channel. There's a special bearing there, but that bearing, you can see it here. There's a spacer here, and then there's a locking collar on the shaft that you use for the large. This is the large 1/4-inch square shaft. This is the large 1/4-inch square. This is the small 1/8-inch diameter square, and it has a little small gear. It's a 12-tooth gear here, a 60-tooth gear here, and that gives you a 5-to-1 ratio on speed and torque. And the motor is going to be attached off this shaft, but it'll have to be a separate mounting structure once you have your vehicle laid out overall. I've showed you the parts. Oh, and I guess this little part here, I will put it in my next assembly stage, but I'm almost thinking that you guys could, those who are keen to move on, could actually build this yourselves and demonstrate that you're moving on. You're sort of self-teaching at that point, and that's a good thing. That's where you really want to get. You want to get to the point where you don't need my kind of help. Here for tools, I'm just using 3 tools: combination open end, box end wrench, a nut driver, the right size for these screws, or for these nuts that we're using on the 832. And then here's, in my case, I'm using hex drive screws. So this is a ball end hex driver, kind of like a screwdriver, except it just goes into this end goes into your hex socket on the screw. I keep a ruler around as a way to measure lengths that I need to have as time goes by. I don't know, I guess that covers everything I can think of that I've got here to show you. Let me step back a little bit, give you a large view. Stuff I'm showing you here. Okay.